Hi, my name is Graham Smith, and I'm one of the authors that helped develop the learning approach to mathematics that is found in our textbook as well as the video you are about to experience. To learn more about our approach to learning mathematics, visit the web address that accompanies this video. Now, enjoy the video. Polygons. This video will help you classify polygons and find their perimeters, classify quadrilaterals, classify triangles, and find the measure of angles in a triangle. Classify polygons and find their perimeters. Let's start with some definitions. A polygon is drawn with line segments that do not cross and form a closed, flat figure. Regular polygons have all sides of the same length and all angles of the same measure. Now let's take a look at some polygons. The first polygons I have listed in this table are 5 common polygons. The first is a triangle, and that polygon has 3 sides. Triangles you probably are very familiar with. The next one is a quadrilateral, and that has 4 sides. The next is a pentagon, 5 sides, hexagon, 6 sides, and an octagon, 8 sides. Now these polygons in this first table here may not look that familiar. However, if we take a look now at these polygons as regular polygons, they probably are going to start to look more familiar. The first is a regular triangle, and notice all sides of the triangle are equal and all angles in the triangle have equal measure. The next is a regular quadrilateral, which you may recognize because it's a square. The next, a regular pentagon, a regular hexagon, and then a regular octagon. Now let's take a look at some examples that will help you understand how to classify polygons. Example 1. Classify each of these polygons. Well, let's take a look at our first polygon we have here. It has 3 sides, so it's a triangle. Notice too that all the sides are equal in measure, and also all of these angles are equal in measure. So that makes this a regular triangle. Let's take a look at our second polygon. Let's count the sides. We have 1, 2, 3, 4, 5 sides. So that's going to make this a pentagon. Notice the sides are the length of the sides are different. So this is not a regular pentagon, so we would just say that this is a pentagon. Let's take a look at our next polygon. We have 1, 2, 3, 4, 5, 6 sides on this. The sides are not equal in length, so this is just a hexagon. Now it's time to check your understanding of classifying a polygon. Hit pause on your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 1. Classify each polygon. Let's take a look at our first polygon we have here. There's 1, 2, 3, 4, 5, 6, 7, 8 sides. The sides are not equal in measure, so we would say that this is an octagon. Let's take a look at this next polygon. We have 1, 2, 3, 4, 5, 6 sides, different measures, so that is just going to be a hexagon. The last figure here, we have 1, 2, 3, 4, 5. Now notice these sides are all equal in length. The angles are equal in measure, so this is a regular figure. Since it has 5 sides, this is a regular pentagon. Quadrilaterals. We're going to start by taking a look at the different types of quadrilaterals. Starting over here on the left, we have just a plain quadrilateral. And in a plain quadrilateral, no sides of the quadrilateral are parallel. Let's take a look at the next one, which is a trapezoid. Specific type of quadrilateral where one pair of sides are parallel. And notice here are my parallel sides. I have this top side and this bottom side. And we use a little arrow on those sides to indicate that those sides are parallel. Take a look at the next quadrilateral, which is a parallelogram. And in a parallelogram, we have 2 pair of sides that are parallel. So just like the trapezoid, we have the top and the bottom parallel, But we also have these other two sides which are parallel. And so I don't want to get these mixed up, so I'll use two arrows on these other sides. So that would indicate that both two pairs of parallel sides. Now, underneath the parallelograms, we have specific types of parallelograms. The first one is a rectangle. A rectangle is a parallelogram because it has two pairs of parallel sides. However, it has one more additional stipulation on that, and that is that all the angles are also 90 degrees. So in a rectangle, we have two sets of parallel sides, and all of these angles measure 90 degrees. Let's take a look over here at the rhombus. So a rhombus still has two pairs of parallel sides. So we have this side and this side are parallel. These two sides are parallel. But on top of having two pairs of parallel sides, all the sides in the rhombus are the same length. And we would indicate that with a little tick mark like this. I would say this, 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 and this. All of those sides now, according to those markings now, have the same length. And finally, the last of these quadrilaterals, which has all of these properties together, is a square. It's still a parallelogram because two sets of parallel sides. A square is also a rectangle because it has all 90-degree angles. So a square is a specific type of rectangle where we have these 90-degree angles. And a square is also a rhombus because all of the sides are equal in length. So it has the property of a rhombus as well. So all of these sides, we would mark that, are equal in length. Now let's take a look at some examples that will help you understand how to classify quadrilaterals. Taking a look here at our example, we have a bunch of different figures. And in example 2, we're asked which figures are quadrilaterals. Well, any figure that has four sides is going to be a quadrilateral. So I think all of these figures are quadrilaterals. Here we have four sides. Here we have four sides. Here, here. So all of these figures are going to be quadrilaterals. So we have A, B, C, D, E, and F are all quadrilaterals. Example 3. Which figures are parallelograms? Well, to have a parallelogram, we have two sets of parallel sides. Well, A has two sets of parallel sides. D also has two sets of parallel sides. Here's one set. There's the other. If you didn't see that. D has two sets of parallel sides. B does not. E does not. C does. So C has two sets of parallel sides. And finally, F does as well. So it looks like the figures that are parallelograms are going to be A, D, C, and F. Now it's time to check your understanding of classifying quadrilaterals. Hit pause on your video player and answer these guided practice questions. When you're done, hit play to see how you did. Question 2. Which figures are rectangles? Well, if the figures are going to be rectangles, they have to have all angles that are equal to 90 degrees. So here A, that has angles that are equal to 90 degrees. B does not, C does not, D does not, E does not, F does though. F also has angles of 90 degrees. So both of these figures, A and F, are rectangles. Notice that F is a square, but a square is a specific type of rectangle. It is still a rectangle. Okay, question 3. Which figures are squares? Well, there's not going to be very many figures that are squares because they have to have all these stipulations. Two sets of parallel sides, sides that are equal in length, and all angles are 90 degrees. Well, there's only one that does that, and that is over here, F, which is our square. Classify triangles. We're going to start with a table that describes a scalene, isosceles, and equilateral triangles. Let's start over here with a scalene triangle. Scalene triangle, no sides are equal and no angles are equal. Let's take a look at an isosceles triangle now. In an isosceles triangle, two sides are equal and two angles are equal. So you can notice here with my marks, little marks like that tell us that the two sides are equal, and then these little angles on the angle here, these little marks on the angle there, tell us that both of those angles are equal in measure. And a special note here, the equal sides and equal angles are opposite one another. So here the equal angle is opposite the side. Here the equal angle is opposite the other equal side. Equilateral triangle. 3 sides are equal and all 3 angles are equal. So here everything about this triangle is equal. We have all 3 sides equal because we have those little marks there, and also all 3 angles are equal. And in an equilateral triangle, all the angles are equal and they also measure 60 degrees. So you'll notice that we have little 60-degree measures here. So any equilateral triangle, all of the angles in there have a measure of 60 degrees. Now we'll take a look at the different types of right triangles that we have. The first type of right triangle is a right scalene triangle. So one angle in this triangle is 90 degrees and the other 2 angles are not equal. And since it's a scalene triangle, none of the other sides are equal in length. None of the sides are equal in length. Let's take a look at a right isosceles triangle. Well, if it's a right triangle, we have to have a 90-degree angle, which we have here. If it's going to be an isosceles triangle, that tells us that 2 of these sides have to be equal in measure. And you can see, according to the marks here, those 2 sides are equal in measure. Now, since this angle is 90 degrees, in any right isosceles triangle, the other 2 angles are going to be 45 degrees. And again, we've already mentioned that the other 2 sides have to be equal in length. Now, if we try to draw a right equilateral triangle over here, it's impossible. We can't do it. It's impossible to draw a right equilateral triangle because every angle in the equilateral triangle, as we already mentioned, has to be 60 degrees. So it can't have any right angles in there because that's a measure of 90 degrees. Now we're going to take a look at a couple other types of triangles. We also have an acute and obtuse triangles. And in an acute triangle, all of the angles are less than 90 degrees. Just the same way that when we had an acute angle, it also had to be less than 90 degrees. So those are the acute triangles, angles that are small. We also have an obtuse triangle, and just like an obtuse angle, an angle in this triangle has to be more than 90 degrees. So we have lots of different types of triangles, and we're about ready to start practice classifying them. Before we do that, let's take a couple hints here about how to do this. To classify triangles, do the following. First, determine the number of equal sides or the number of equal angles. Then determine if one of the angles is a right angle, has a measure of 90 degrees. And then finally, if the triangle is not a right triangle, decide if the triangle is an acute or an obtuse triangle. Now we're going to take a look at some examples that will help you understand how to classify triangles. Example 4. Which figures are right isosceles triangles? Well, if they're going to be right isosceles triangles, the right part tells me that I have to have a 90-degree angle in the triangle. The isosceles part tells me that 2 of the sides also have to be equal. So let's start with our right triangles. Here's a right triangle. It has a 90-degree angle. Here is a right triangle. Now, for it to be a right isosceles triangle, 2 of the sides have to be equal. Well, A does not have that criteria. However, E does. Here are my sides that are equal in measure. So E is a right isosceles triangle. Example 5. Which figures are obtuse triangles? Well, if it's going to be an obtuse triangle, that means it has to have an obtuse angle in it, which means greater than 90 degrees. So let's take a look at these triangles. A, the largest angle in there is this 90-degree angle. So that's not going to work. B, all of those angles are smaller than 90 degrees. C, however, has this large angle right there. That is an obtuse angle, so C is good. And D, nope, all of those angles are smaller than 90 degrees. E, the largest angle there is 90 degrees. So it looks just like that C is the obtuse triangle. Example 6. Which figures are isosceles triangles? Well, if it's going to be just an isosceles triangle, it means it has to have 2 equal sides, at least 2 equal sides. So B, here is an equal side, that equals that side, so B is an isosceles triangle. A is not, C is not. D, even though this is an equilateral triangle, it still is an isosceles triangle because it has at least 2 sides that are equal. So D is also an isosceles triangle. And finally, as we mentioned before, E is an isosceles triangle. Now it's time to check your understanding of classifying triangles. Hit pause on your video player and answer these guided practice questions. When you're done, hit play to see how you did. Question 4. Which figures are acute triangles? Well, for them to be an acute triangle, they're going to have an acute angle in them, which means less than 90 degrees. In fact, all of the angles in there have to be less than 90 degrees. So A is not going to work. It has an angle of 90 degrees. That won't work. B, however, will, because all of these angles in B are less than 90 degrees. C, nope, that won't work. D, yes, D will work. All of those angles there are less than 90 degrees. E will not work because it has an angle of 90 degrees. So just B and D are the acute triangles. Question 5. Which figures are equilateral triangles? Well, equilateral triangles means all sides have to be equal, and that is only this figure here in D. There, all the sides are equal, so D is my only equilateral triangle. Question 6. Which figures are right scalene triangles? Well, a right scalene triangle has to have two things here. First, it has to have a right angle. So A and E have the right angles. Now, if it's going to be scalene, that means all the sides have to be different lengths. Well, in E, we had these two sides that were the same length, so that's not going to be a scalene triangle. So it's just going to be A is our right scalene triangle. Find the measure of angles in a triangle. Even though triangles come in all shapes and sizes, the sum of the angles in each triangle adds up to 180 degrees. We can use this fact to find the lengths of missing angle measures in a triangle. Now let's take a look at an example that will help you understand how to find a missing angle measure in a triangle. Example 7. Find the measure of the missing angle. So this is what we're trying to find, the measure of this angle x. Notice the other two angles are given here. We have a measure of 40 degrees and the other angle has a measure of 116 degrees. We just learned that the sum of the angles in a triangle has to add up to 180. So let's write that as an equation here. If I take that first angle, 40 degrees, plus the next angle, 116 degrees, plus our missing angle, all three of those angles have to add up to give me 180 degrees. Let's simplify and solve this equation. On the left, we're going to start by adding 40 and 116 together. When I add 40 plus 116, that's going to give me 156. Plus this missing angle x is going to have to add up to be 180 degrees. Now, I want to solve for x, so I want to get rid of that 156 on the left side. To do that, I'm going to subtract. So I would subtract 156, subtract 156. On the left side, 156 minus 156 is 0, so I'm left with just this missing angle measure x. On the right side, I have to do the subtraction, 156 from 180. Well, to do that, we'll need to borrow from the 8 to make it a 7. It makes that a 10. 10 minus 6 is 4. 7 minus 5 is 2. 1 minus 1 is 0. So it looks like our missing angle measure here is 24 degrees. Now it's time to check your understanding of solving for a missing angle measure in a triangle. Hit pause on your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 7. Find the measure of the missing angle in this triangle. Well, again, the sum of these angles is going to have to add up to 180 degrees. And even though this one isn't listed, we have the box there which tells us this is a right angle, so that angle has to be 90 degrees. So if I take x plus 90 plus 45, all three of those angles have to add up to 180 degrees. And now we're just going to solve for x. So let's see. I'm going to add the 90 and the 45 together first. So I'll get x degrees. 90 plus 45 is 135 equals 180. Now I need to solve for x, which means I need to get it all alone on this left side. To do that, I'm going to subtract this 135, and then I'm going to do the same thing to the other side of the equation. And let's take a look. On the left side, 135 minus 135 is 0, so I'm left with just this missing angle measure, x. On the right side, I need to subtract 135 from 180. So let's see, to do that, I'll need to borrow from the 8, which makes it a 7. We'll make that 0 a 10. 10 minus 5 is 5. 7 minus 3 is 4. 1 minus 1 is 1. So 1 minus 1 is 0. So I'm left with 45 degrees. So the missing angle measure there is going to be 45 degrees. If you found this video helpful, I encourage you to check out our other videos that we have on YouTube, or visit the web address that accompanies this video to learn more about our approach to learning mathematics.